Hi. On our last video, we looked at parallel line development of T's, and we looked at an equal diameter 90-degree T. Today we're going to look at an unequal diameter, still perpendicular off the pipe, so we still have a 90-degree section here, but it's a smaller T than it. We'll start with that. Now, first thing we want to do is establish our plan and elevation view. So let's go ahead and draw that in. So now we have our full side elevation and end view. We can start to establish our miter line and then go into our stretch out and pattern from there. But what we want to look at is a couple of things first. Now, we know that with parallel line, the objective is we're trying to find the length of the element lines, and it depends where that miter line hits on the pipe to how long they are. It might come all the way down to the bottom if it was equal diameter. In this case, we know it stays fairly shallow, but we don't know those exact heights yet because we don't know where the miter line will hit. But if we look at this view here, we can see that these heights, if we project them across, that is our height. So at each of these points here, they will come across, they will intersect the corresponding vertical element lines, and that's going to establish our miter line. So going forward, there are more shortcuts we can take. Now, it's important to note that anytime we take shortcuts, you want to be really comfortable with the process. It's always a good idea to get a really good grip on the concepts that we're working on here and seeing the different views and visualizing that before you start taking any shortcuts. And we can always go back to full side elevation, full end elevation for any parallel line development that we need. So let's bring these across and see where they hit. And we get that. Now let's put our numbers on so we can follow where we're going. And I'm just going to use 7 in this case. Now remember, last time we're flipping our view, so we end up with 1/7 on center here, and 4 will spread out. And we end up with this. Now, it doesn't matter which way we go, left or right to start, but we want to follow our number line, just like we did on the last video. So 1, 2, 3, 4, 5, 6, 7, 6, 5, 4, 3, 2, 1. So opposite views. This one we want to keep more of the overlaying points just to keep track of it so we can follow our number line properly. And now we could create our stretch out and send that in. So now we have our stretch out drawn, and our last video we just projected these lines into our stretch out. Now we know that the T itself doesn't come past this level of the pipe, but we always make our blank size all the way to the bottom or center line of the pipe plus the total height of the T. We're going to end up with some scrap, but that's a really easy way to calculate it is the radius here plus the height at center of the T will give us the blank size for our part. We don't want to try and calculate where this actually hits. So always from center to the top will be our blank size. So this dimension here. Now we looked at it last video, two different ways that we can get our lines in there. We can merely pick up if we want to have, let's put our seam at the short side again, 0.1, and I pick up 0.1, and I'm going to take that over and I'm going to swing it here, and I'm going to swing it from the top because that's where I'm picking up my point. I'm not picking it up from down here, or not really concerned with the top of the pipe, even though it does land there, but I'm picking it up from the top is sort of our baseline or datum point at this point. So we go backwards from top to bottom. And pick up the next one. And I'll swing it. Now let's get some numbers on here to match. And we can carry on with our dividers, all of our corresponding lines. That's our first option. Our second is to merely project the lines across. Now, we projected from here into our side elevation, so those are the same. So we can merely project from this point here, from this view. That, remember, gives us all of our heights that we require. And we project those lines across. Our next one is 3, so there's 3 there. And then 4 is there. And we run those all across. Now let's look at a couple things that we can identify now. What we know, because this is perpendicular, because it's straight up and down, our heights here will be the same as our heights here. We did this to establish our miter line, but really we have an idea of what it is in here, because we can see exactly where it hits the pipe. We could project straight from this view into our pattern. So let's see what happens when we get rid of this complete view. Again, this shortcutting is only when you have a good grasp on the concepts. So now we look at just the end elevation. We have the pipe here and the T. Our element lines are in green, the profile's in pink. And we've profiled it, brought our lines down. Where they hit the pipe, we bring them into our stretch out. We also have a mirror image left to right. So let's take off a few of those just to visualize things. And I'm just going to remove this for a minute. We end up with something like that. Still have our 4 lines. And we still have a way to project those in. Now, where we can shortcut this even further is what establishes our height here is a combination of things. We have first what we refer to as our seam height of our T, which is here. And I'll label that seam height. So we have this dimension. And that would be given in our drawing of how tall we want the T. It doesn't matter how tall it is. And we brought that over, that's our 0.1 here. So that continues on, and it's our first point. So we know that this distance on our blank size is consistent from our end view into the pattern here. And we could bring that all the way across just to show us. That's still our seam height here at 0.1. So the way it turns out, the important part of this view is where the T hits the pipe. It's these spots right here that's important. We know the seam height. We need to find 3 points in there. Now, if I moved this profile taller and projected them down, we'll hit the same point on the pipe. It doesn't matter how tall it is. And being that this is a given dimension, all we're looking for is the 3 points. So we can move it up, we could also move it down. So let's try that. Let me set to my radius here. And if I swing it in below, inside the pipe, and I divide it, we end up with that. And I'll bring those lines up now instead of down. And notice what we have. We have the same intersection points. We still end up with our 3 points here to project into our pattern. So that can get rid of this whole part of the drawing for us. And now we're left with that. So significant drop in amount of drawing that were required. And let's do one more thing here. If I take our radius of our pipe, and let's put our radius here, and that should land at our seam height. Pipe radius. And let's also take our T radius and put it in and divide the T. We're always dividing the T. And bring our points up to where they hit the pipe. Same projection points here as we had here, which was the whole drawing that we had before. So we can simplify the whole T down to 2 half profiles or quarter circles. We have our given seam height, that's our top of our blank size. The bottom of our blank size is the radius of the pipe. That's the maximum it could ever come to, is midway of the pipe. We swing our pipe at the bottom, we swing our T inside of that, divide our T, bring them up, and run our lines across. And those will be in the same points as our projection was earlier. And then if we want to, we want 1 is here, 2, 3, 4, 5, 6, 7. And we'll run that all the way through. You also can notice, I always circle my intersection points. Don't put a dot right on the center of it because you lose your accuracy. So if we go and run these through, and if I lined up all my lines, they would follow a pattern which any on-center T will. And the pattern becomes over one space, down one space, over one, down one, over one, down one. And then when you hit the bottom, you reverse, over one, up one, until you hit the top, reverses again, and you end at the same spot that you started. And there's our pattern. Now, this particularly is the way that we want to practice doing it in the shop. If we think of the original drawing we had with the full plan, full elevations, front elevation, side elevation, that's a lot to draw in a shop setting. This, we can calculate our blank, seam height, half the pipe, circumference, put 2 quarter circles in on the blank size, and create our pattern right on our blank sides of metal. So this is what we refer to as the shop method. That's unequal diameter, 90-degree T.